Welcome to Cloudy with a Chance of Podcast. I'm Chief Meteorologist McCall Vrydaghs here with Meteorologist Kirstie Zontini. As always, my co-host, we are so excited for this episode of Cloudy with a Chance of Podcast. For all you weather enthusiasts and all you climate enthusiasts, this is the episode that you certainly want to listen to and watch to. So, you know what? Let's not gab about anything else and get right to it, Kirstie. So introduce our guest today.
Yes, we have a special guest. Our last episode, we talked a lot about climate with Dr. Marshall Shepard. And so this time around, we're continuing on with that theme and our changing climate. So we thought we would have Sean Sublette on with us. He has quite an interesting background. Not only did he go to Penn State for his master's as well as his undergrad, he's from Richmond, Virginia. He was a television meteorologist for several years in Roanoke. He worked for NASA briefly, just, casually we'll put that in there as well. But most recently, he is with Climate Central, which is a wonderful resource for us meteorologists and for other people in the weather community. They provide data, resources, visual help for kind of explaining the story of our changing climate and what is going on and how our climate warming is impacting, not only us here in Ohio and Dayton, Ohio, but what's going on across the globe, what's going on with hurricane season. So they're a fantastic resource that we use a lot. And so we wanted to bring Sean on to talk a little bit more. So welcome, Sean.
Thank you, Kirstie, very much. And McCall, thank you very much for having me. Appreciate the wonderful introduction as well.
Kirstie's really good with those introductions.
I have a lot of fun writing them. So, Sean, tell us a little bit about Climate Central first. If someone is just listening and they're like, what is that? What's that?
Yeah, we've been around for about 10 years. We're a nonprofit organization based just outside of Princeton, New Jersey. Our office is actually physically there in Princeton, New Jersey. We're not affiliated directly with the university. The people on our governing board are largely, not exclusively, but largely Princeton alums. And about 10 years or so ago, they kind of came together with the idea of, we know the climate is changing, and there's no one good resource, a media-friendly resource to help get climate information out to the people, to the public. So that's kind of why we were created about 10 years ago. And our program has grown tremendously, especially the last 2 or 3 years. The project I work on is called Climate Matters. And that's the one where we interact with meteorologists and journalists across the country, basically helping to provide resources for letting them tell the local climate story, how it impacts their audiences. Because, climate change is a big, thorny global issue.
Right.
And people deservedly want to know, what does it mean for me in my daily livelihood? What does it mean for me 10 years from now, for my kids, for my grandkids, whether I live in Dayton or Cleveland or Cincinnati or Indianapolis or wherever. And we do serve areas all across the country. So we're always here to help people tell the story that they want to tell. We're not here to dictate to anybody what they ought to be talking about.
Yeah. As a meteorologist at WHIO TV, we get your emails, which are fantastic because, as you mentioned, the everyday person, it's hard to digest the whole climate change idea, and how you can make it so specific for the Dayton area or our region is fantastic. But that is a lot of data and a lot of undertaking. Where is this data coming from?
Most of the data in our regular analyses are largely just provided by NOAA, National Weather Service, the National Oceanic and Atmospheric Administration. It's all publicly available. One of the portals we use for the data is called the Applied Climate Information System. But again, that's NOAA data, and we just compile it. We run some code. We have a couple of very sharp multimedia artists, and we put together the graphics that we think are visually pleasing to put either on the air or on social media to help illustrate what the climate has been doing largely the last 40 or 50 years in any particular spot. Obviously, climate goes before 50 years. Yes. A lot of our analyses do start in 1970 because we're serving more than 200 cities. And, we're not a big organization. We like to think big, but we're a pretty small organization. So we have to automate a lot of that, computer code writing, a lot of the Adobe Illustrator stuff. We kind of have to automate a lot of that. And once we go before 1970, we start to see a lot of gaps in the data in a lot of the cities that we serve. So that's one of the reasons that a lot of our analyses go back only about 50 years. And some places in the country were kind of cool in the early 70s, some places were hotter in the early 70s, but everybody gets 1970 unless we could find another reason data-wise to go back earlier, or what the data is available.
Well, I think it's important hearing this because it could be confusing, or people may make assumptions that maybe you're collecting your own data, but this is data that, is through NOAA. The same data that I might go to NOAA and show on TV is the same data that you're providing as well, in just a very beautiful and easy, digestible type of way. Has there been anything since you guys have really started doing this that you've kind of honed in on, that you've noticed there is a dramatic change in the climate in any particular type of avenue?
It's incremental. I mean, a lot of times we'll hear folks in the climate science community talk about how fast this is happening. And it is happening fast when we think about a longer scale, geological kind of time scale. I always kind of worry about that, because for most people, fast means it all changes in a week.
Right.
What we use in terms of our adjectives we might use may not resonate as well. For the individual person, this summer and last summer aren't that much different. But there was some polling, and I forget the name of the organization, came out 2 or 3 weeks ago, that suggested a lot of people who are over 60 years old, a majority of people, despite any kind of ideological affiliation, have all kind of it's hotter now than it was when I was a kid. And the data bears that out. There's, to be fair, in some of our analyses, we see trends that are stronger than others. A lot of that is more of a micro influence, like, hey, did we move the thermometer from
weather
this side of the
state,
airport to this side of the airport? Did we move it from downtown to an airport? And that's not something we can control for 200 cities at once. We go, as McCall said, we use the same data that y'all use. Whatever that data is using, that's what we're using, so you can corroborate against it. There are a few exceptions. Like next week, we are publishing a report in concert, or coincidentally, with a big paper that's coming out from Columbia University about agricultural yields, both in corn and soybeans, and how they are projected to decrease in a warming climate, especially for the second half of the century. So that's coming out next week. So we're really trying to make an effort to move beyond just, here's a graphic that shows you how hot it's getting, to show how these things are going to be impacted, to go back and look at some of the current research that's being done at places across the country, and take some things that are very tangible to people, to try to make more of a connection to what the warming climate actually means for people, versus just like, it's warming, so what?
Right. And I think that that's good too, because, especially being in Ohio, obviously corn, soybeans, that's a commodity that's grown here. And sometimes, having an analysis or the paper that'll come out next week is going to be a good example for us locally, because we think of climate change and it's probably, or maybe a little bit more noticeable or tangible to those along the coastline, where we have impacts from hurricanes, or where we're seeing that coastal erosion and that kind of thing. So sometimes in Ohio, I feel like the message can kind of get a little lost. So having some of that analysis from Climate Central is I think beneficial, like you said, to take not just these numbers that we can show on the graphics, but then also show like, hey, this can impact agriculture too. It's not just, along the coasts of the United States.
Yeah, I mean, the coastal locations do get a lot of press, to be sure. There's very high populations along the East Coast and West Coast. And we do have another program that's all about, sea level rise, and illustrating how that's going to play out along the coast, depending on how emissions go here in these next 10 or 20 years, because there's so much coastal infrastructure in the country. But when I think about the Midwest, I think about Ohio, I think about Indiana, I think about Kentucky, and I think about what can we say about a warming climate in those locations. We know that winters are warming faster than any other time of year. And that kind of makes sense. You put more energy into something that is cool compared to more energy into something, the same amount of energy, into something that is relatively warm. The cooler thing warms up more. I mean, you can do that kind of experiment at home with just a glass of water and on the stove. So winters are warming most. And in Dayton in particular, analysis we ran at the beginning of 2020 shows that snow is on the decline over the last 50 years in Dayton. During the dead of winter, about 3 inches less a year.
Yeah.
Now, snow is notoriously difficult. The snow
Right.
data is notoriously difficult and thorny because how you measure snow, where you measure snow, all those things have been inconsistent through time. All right, so there's always that caveat.
Yeah.
But we try to do this for as many places in the United States that do report snow, so we could see if there was something there. And we found a lot of places at about the latitude of Dayton and farther south where they still get
Right.
snow, you know, Kentucky, low downstate Illinois, West Virginia. Some of those places in the dead of winter are still getting about the same snow or a little less. Farther north in the dead of winter, they're actually getting more, which is counterintuitive. But those places are so cold to begin with during the dead of winter. You know, their average temperature is 25, 26 degrees.
Right.
So if their average temperature goes up to 28, 29 degrees, still warming, still below freezing, as y'all know, if the temperature goes up, there's more moisture in the atmosphere.
Yeah.
When it's saturated. So you get more snow because you're still below freezing.
Right.
I think in time, 30, 40 years from now, that kind of, you know, the seasonal rain snow line will probably move farther north. But we see more of a trend in what we call the shoulder months, the late fall, early spring snows. In most places across the country, those are going down. The one exception to that is along the northeast coast, and back to the coast. Those big nor'easters that you hear about, they can produce more snow in an individual storm, again, because it's still below freezing, but there's more moisture available. So over the long term, snow is going down, even though there might be little bursts here and there that are still very strong regarding snow. But sometimes it's hard to explain to people. You go outside, look, there's 14 inches of snow on the ground.
Right.
Where's my global warming? I'm like, well, it's just one day. It's like, it's like, and I'm not that I'm shilling for Tom Brady here. I think most people know he's I think most people know he's a good quarterback, whether you like it or not. But that dude's going to the Hall of Fame.
Right.
You can't say, but he's going to have bad games. He's going to throw. He's going to have a couple of bad games. He's going to throw interceptions. I mean, you can't just go watch one or two plays from Tom Brady where he had a bad series, he went 3 and out, and go, he's horrible. He's just horrible. You've got to look at the long term, what the whole season, or whole career is. Same thing with the climate. You can't just look at this is what it was like today. So
Right.
It doesn't work that way. It doesn't work that way.
And I think that's the most interesting part about studying the climate and seeing how it's changing, because we're seeing more and more, not necessarily higher frequency, but more intense of an event, whether it's a nor'easter that's going to drop a ton of snow, but we haven't had a ton of nor'easters that season. Or for us in particular in the Miami Valley, having the largest tornado outbreak that we've ever had with 15 tornadoes, where in a typical year, we'll have a couple tornadoes here, a couple tornadoes here, but nothing that's going to bring us EF3s and EF4s. So having more tornadoes on one particular day rather than spaced out throughout the season. So I think that's quite interesting as the climate is changing. The intensity of these systems are increasing. But I wanted to ask you a question because going back to how we were talking about the corn yields, and, for us, I was actually having a recent conversation about bugs, having more bugs. We just had army worms, which aren't necessarily something that is very common for our area. And that's because we're getting warmer. So these bugs and wildlife that is normally staying to the south is kind of inching up a little bit further north. How are you getting data on those type of things as far as more mosquitoes, more ticks, things like that?
Those things are a lot harder, to be absolutely fair, and they're harder to trace, that they're harder to get a handle on. We've done a couple of analyses on mosquitoes where we've looked at some research papers that say, okay, the optimum temperatures where mosquitoes proliferate are, and I forget the precise numbers, but it's between, I think, 55 and 90 degrees or about that. And obviously with a more humid environment. Right. So we would look at where's the temperature range been historically in cities across the country? Where is it now? Where is it kind of projected to go? And that's how we kind of use that as a proxy to determine, well, how much more mosquito is going to be prevalent now and into the future, because the temperatures are more consistently in a level or a range that allows them to proliferate. So that's one way we kind of work through that, because yeah, it's hard to measure. This is how many mosquitoes per cubic whatever are out there. You know, is it just the way we kind of interpret it, or is it actually changing?
Right.
So, and we lean a lot on other published research for just that reason. It's like this paper coming out from Columbia University next week. That research was largely done outside of our office, but we kind of feel like this is important research to kind of amplify. This is an important paper with big ramifications. So, you know, we talk with the authors, and they, be fair, they give us a little data ahead of time, as long as we say, as long as it's like, don't put the data out till the paper's out.
Yeah. Yes, we
Totally
get
get
that.
We respect that.
Right.
But that way we can get the word out as effectively as we can about the research they're doing and what the impacts are for the people living in those areas. And this should show that corn yields are probably going to be going down across most of the country in the second half of this century. And we know it's tough enough for farmers as it is. I mean,
Right.
just 2 or 3 seasons ago, it was so wet, it was hard to get crops in the ground.
Yeah.
We talked to some folks in Toledo about that 2 or 3 years ago.
Yep.
But one of the things we know about the supercharged water cycle, I say that because if it's warmer, you're going to have a more excited water cycle. Evaporation, condensation, precipitation, all that ratchets up. So as a very, very short version in a warming climate, the places that tend to be moist or wet will get wetter. Places that tend to be arid or dry will get drier. I mean, as I'm sure you've told your viewers, it's just brutal in the Intermountain West and you know, west of the Front Range of the Rockies. The drought's just horrible, horrible. I mean, Lake Mead is at the level that it has never been at since it was filled out there along the Colorado River back in the 1930s. So there are certainly challenges that are going to have to be met as we go forward these next few decades.
What is, I mean, obviously the goal is to continue to share the information of our changing climate to, you know, people I think are sometimes just, like you said, honed in on today, tomorrow, and the next week. Sometimes it can be overwhelming to start digesting what's happening out in the future, what we're predicting and what we have seen over the past several centuries. Or decades. So I guess what is the goal of Climate Central in terms of helping to get that digestible information out? You know, what are we hoping, I guess, for the average person?
Well, we want to be sure that the average person has a good understanding of where the science is, what it means for them. And then it's kind of up to the individuals to decide what they want to do with that information. But we want to be sure that we get the most accurate information out there possible. You know, people are busy. So that's why we try to put together some products that will give somebody a glimpse. If they have 5 seconds to look at a graphic on your air or scroll through social media, to give them a snapshot about where things are and where they might be going. And then say, well, this is what you can expect as you go forward in time for your kids and then for your grandkids. You know, we tried, you know, my son was in Boy Scouts and we would go on campsites and the reminder was you leave it in a better condition than what you found it in.
Yes.
You know, so that's what I want people to kind of remember. I mean, I don't expect us all to stop driving and go live in a cave. No. But, you know, we need to think about the decisions we make about consumption. We need to think about the decisions we make about how energy is generated. I mean, more than half of the carbon emissions are from our electrical grid and transportation, about 55% of that. So if we can shut those down, again, I say shut down, probably not the best choice of words. We can back those off, find other ways to get around, generate electricity without setting carbon on fire, as my friend in Colorado State says. That helps us out a lot. That's a big piece of the puzzle. You know, so many times we want it to be an easy answer. It's not. It's not like, oh, we just put windmills everywhere and it's fine. No, that's not gonna work. Those are important pieces of the puzzle, but it's not the complete puzzle. You know, we do need to ratchet up efficiency. We need to stop setting carbon on fire. I mean, MIT over in Massachusetts put out a press release last week about they've discovered or they've been able to perfect a new magnetic field. Like, what does that mean? Well, that means if you want this whole fusion energy to happen, you need to contain this reaction. this very, very, very hot reaction, and they do that in a big magnetic field. So, fusion is a wonderful concept if we can ever get it to happen. But ever since I was a kid, I've heard fusion's about 20, 30 years away. They've been saying that since the 70s. So I don't want to count on that.
Yes.
We should start working with technologies we have and then continue to innovate, because I want us as a country to be strong, innovate. And I hear a lot about, well, what about that country? Or what about that country? I'm like, well, this is all coming. Renewables are coming. These things are coming. So I would rather develop technology here and sell it to somebody else than the other way around.
Right.
Yeah.
Right. Now, talking about climate change, 10 years ago, 20 years ago was kind of a very hard topic to talk about. And I know as a TV meteorologist, it was even just recent that it's starting to be a little bit easier for us to go on TV and do a podcast and talk about climate change. How have you felt the change since not only working at Climate Central, but over the years and advocating for climate change?
Well, we have seen a sea change in how people have discussed it, especially the last 12 months or so.
Right.
As little as 2 or 3 years ago, people were still very hesitant, because it isn't so much the science, but one of the things I've learned since taking this position 6 or 7 years ago, is we have to do a lot of social science to try to understand why people are so put off by some of this information. And a lot of it is what's termed solution aversion. I'm going to have to start doing something I don't want to do. That's the very short version. Or somebody's going to tell me to do something I don't want to do. I'm just trying to live my life. I don't need somebody else telling me how to run my life. All fair. Okay. And one of the things we try to remind people is that I don't care if you eat a hamburger. I don't care what kind of car you drive. That's your business. So, but at some point, all of our decisions collectively do sum up. They do bubble up. So think about the little things, whether I recycle, I don't want to use a plastic bag, I am a vegetarian, or whatever that thing is. Whatever that thing is that you can do to help, do it. It does add up. So it's bottom up and it is top down. We do, there's this, what we call around the office, COP26, the Council of the Parties, the next climate change, summit, if you will, in Glasgow, Scotland, coming up in November. And this is where countries across the planet this is what we said we do when we met in Paris, and this is where it is. This is what we still need to do. This is what I want to do. This is what I think you guys should do. Is all of that going to happen? If the pandemic has waned enough, there's still a lot of talk about whether that thing is still going to happen in Glasgow in just 6 or 8 weeks from now. We think it is, but we're not positive yet. So the little things do add up, but we also need some bigger ideas as well.
And I think that's hitting the nail on the head, Kirstie. You've talked about this time and time again, that it may feel overwhelming to hear about it and feeling like I'm one person and it's such a heavy lift. But Kirstie, you've said a lot, just, doing one little thing is going to help the problem.
Yeah. And I would say also, Sean, just maybe to get your perspective as a scientist, for people that are listening that maybe have kids that are in school that love engineering or love meteorology or love math. It's also, now that we're talking more about what is going on with our climate, you have hopefully a younger generation that maybe they are going to be the person that discovers the solution or discovers a more efficient car for us, or a better way to harness energy that would be safer for the environment. So I guess what would you say to anyone that's listening that might be, hesitant to go into a science field, or maybe nervous to continue pursuing engineering, or is in college right now? I guess what would you say? Because some of it is going to be the generation coming up that will maybe be the next great mind that could help with this.
Yeah, stay on it, because we need people to innovate, and we need new ideas. We need imaginative ideas.
Yeah.
Battery technology is getting better. We talk about renewables with wind turbines and solar, but what happens when it's night and there's not a lot of wind blowing? Well, battery technology, and it's not just a 9-volt battery, but I mean these humongous industrial size batteries to store that power and then release it back onto the grid when it's needed. So we need innovations like that to scale. Again, the whole fusion thing I was talking about. You have to think outside the box, and that's quantum physics kind of stuff. That's heavy duty science and STEM stuff. So we need these big time ideas to see if we can scale them up into something that's going to really be a solution to help keep us on a planet that is, I'm always cautioned to say like it's a livable planet. Planet isn't going anywhere.
Right.
The people who suffer the most from a climate that is getting too hot or too warm or whatever are the people who've least caused it. Unfortunately, people who can't get out of harm's way, they don't have the means. All right. So this is why you hear that so much. It disproportionately affects those people who have done the least amount to cause the problem, whether they live in sub-Saharan Africa, whether they live in Southeast Asia, or whether they live in an inner city and they don't have a car and they're struggling to make ends meet. Those are the people that unfortunately end up suffering the most from it. I'm lucky, I can get in a car and drive somewhere. Not everybody can do that. And sometimes we forget those things.
Yeah. I feel like it was almost a very in our face reminder actually of that with Hurricane Ida. A lot of people couldn't leave. It was literally like they just didn't have the means to be able to evacuate. So with this hurricane season, and I kind of do want to transition to talk a little bit about some of the research now and data that's been released about hurricane season, what's going on with our hurricanes now as they continue to change, and how have you picked up on any changes with hurricane season?
Yeah, the trouble with hurricanes, and this is similar to tornadoes, is there's not that many of them to study. I mean, we get a few a year, a few years a lot more than others, but again, detection is an issue, data collection is an issue. Since the satellite era, we've done pretty well, but that's only about 40 or 50 years. We know there were hurricanes in the 1940s and 50s. We know some of the worst hurricanes in terms of loss of life were early 20th century. I think everybody in weather knows about the Galveston hurricane in 1900. So there have always been hurricanes. Let's be clear on that. But there is emerging evidence now with the data that is out there that hurricanes are starting to go rapid intensification more than they have in the past. That means that they increase their maximum sustained winds about 35 knots, 40 miles an hour in 24 hours or less. That's the mathematical definition of rapid intensification. And there's already a lot of evidence to show that hurricanes are reaching their strongest intensity farther north or away from the tropics. Suggesting, which is consistent with what we know about warmer water, and because that's the main fuel for hurricanes. Those are the two things that I think about the most. And then coastal flooding, storm surge, knowing that the average sea level globally is up about 8-9 inches in the last 100 years. So even if the hurricane itself isn't any stronger than it was 50 years ago, when there is a surge, the surge is higher and goes farther inland. Again, that's a coastal problem, not a big problem for Dayton. But what I do think about inland areas is when these storms do keep their moisture as they move a lot farther inland to a place like New York or Dayton, they still put down phenomenal amounts of rain. And we know tropical systems as a rule are very efficient rain producers. So I try to remind people that what we see in these kinds of storms, disasters, if you will, climate change makes something that was very bad worse. There have always been natural disasters, of course, but this just adds an extra little element on the top. And getting that quantitatively, putting a number on that is hard. Going through a lot of the research, if you wanted to distill this into a figure, and some people will fuss at me for this, it's fine. But I would say in general, things are about 10% worse. Whether that's, you probably got about 10% more rain, or the temperature might have been 10% higher, those kinds of things. Just a ballpark, just to wrap your head around how much worse. Is it twice as bad? Probably not twice as bad, but 10%. And again, that doesn't sound like a lot, but it takes a 6.5 inch storm, makes it 7.5 inches, maybe 7.5. And maybe that's just enough where the drainage system can't handle it.
Right.
Yeah. And we've
And
seen that in, some areas where the infrastructure just isn't set up for that type of rain event, or whether it's heat, northwest of the United States where Seattle's hitting triple digits,
yeah.
people just don't have the air conditioning that you would have in the deep south. So we only have a couple of minutes left here, and I don't want you to get it cut off. So if the average person wants to learn about Climate Central, where can they go to find this information?
All of our stuff is at climatecentral.org.
Very
That's
easy.
the easy part. All the information that we provide to media is public. I mean, as soon as we send out the email alerts to all of our colleagues, it goes right to our media library on the website. That's medialibrary.climatecentral.org. So it's all right there for anybody who wants to use it. And I don't want to emphasize, you could go down the rabbit hole. We could do this for hours.
Yeah, we could.
We don't
Right.
solve this in 40 or 50 minutes. Also would have been solved already. But we have to do little things and big things at the same time to keep the temperatures from getting way out of hand. Right now, it looks like we're on a track that's going to take the temperatures up 7 or 8 degrees Fahrenheit by the end of the century, unless we cut back on emission. And well, it's not so bad, but we know about the ice age 15 to 20,000 years ago. All right. When glaciers were down to New York and Chicago. All right. The average temperature of the planet was only 10 degrees colder then.
Wow.
All right. It's not like the whole planet was 40 degrees colder. So we had ice in Chicago. No, it was only 10 degrees colder.
That's perspective.
So that shows you that a little bit of an average temperature for an entire planet is a lot. It's a lot. So think about taking it the other way. Think about the climate of Dayton being much more like the climate of Shreveport, Louisiana.
Right.
That's kind of what we're thinking of, to try to visualize it a little better. Legacy crops, agriculture that you've had isn't going to work anymore 50 or 60 years from now. You're going to have to adjust. And of course, nature is going to have a harder time adjusting because it just doesn't adjust as fast as you or I do.
That's right. Well, Sean, thank you so much for joining us. As you said, we could talk about this for a really long time. So we'll probably have to have you on for another episode down the line. So if you want to hear that episode, you have to make sure that you're subscribed to Cloudy with a Chance of Podcast. You can do that anywhere you have a podcast app, and you can check it out on Google Play, Stitcher, WHIO.com. We will have a video version online. And also we have a YouTube account. So we're going to upload this video version there as well. As always, thank you for joining us on Cloudy with a Chance of Podcast. We'll see you next time.
Thank you.